Okay, so I am going to show you how to work the last 3 demo problems from class, the ones that you were supposed to work on your own as, and this way you can see if you did them right before you start on your homework tonight, or you can refer back to them as you're working on tonight's homework. Remember, this is the ideal gas law. So we're only going to be dealing with gases that are behaving ideally. So review what those qualifications are, but you can assume that each of these 3 gases are that way. Remember that the formula for the ideal gas law is PV, pressure, volume, equals N, which stands for moles, R, which is your gas constant, and T, which is your temperature, always, always, always in Kelvin. All right, so let's look at problem number 4 up here. If I have 7.7 moles of a gas at a pressure of 0.090 atmospheres and at a temperature of 56 degrees Celsius, what is the volume of the container that the gas is in? So what you're going to want to do is you're going to want to just fill in what you know to your formula and then solve for the one you don't. So we start with pressure. Pressure said it was 0.090 atmospheres. Volume. Well, what is the volume of the container? That's what we're trying to solve. So we're just going to let that be a variable. Equals N, which is your number of moles, which it says in the problem 7.7 moles. R is your constant. So when you're dealing with atmospheres as your pressure, your gas constant is always 0.0821. And then your temperature is going to be 56 degrees Celsius, but remember we've got to convert that to Kelvin, so 56 plus 273 is going to give us 329. Now to solve for volume, all we have to do is divide both sides by 0.090. And you will get that volume equals 2,310 liters. Now, we've got to look at significant digits. There's only 2 significant digits in each of our measurements. So really, this becomes 2,300 liters so that you've got proper significant digits. All right. For number 5, if I have 17 moles of gas at a temperature of 67 degrees Celsius and a volume of 88.89 liters, what is the pressure of the gas? I'm going to use this formula down here at the bottom, same way. Pressure now, though, is the variable we're trying to find. So we're just going to let that be P times a volume, and it said that was 88.89 liters. Equals moles. That's what the N stands for, is moles. So 17 moles times your gas constant. We're dealing with atmosphere as our pressure, so we're going to use that 0.0821 as our gas constant. And then a temperature of 67 degrees, which comes out to be 340 Kelvin. So here, to solve for pressure, all we have to do is divide by 88.89. And you're going to get a pressure that is equal to 5.3 atmospheres. Okay, our last demo problem for the day is number 6. If I have an unknown quantity of gas at a pressure of 0.50 atmospheres, a volume of 25 liters, and a temperature of 300 Kelvin, how many moles of gas do I have? Again, we're still using that PV equals nRT formula. I encourage you to write that down every single time and then just fill in what you know. So our pressure, it told us, was 0.5 atmospheres. Our volume, it told us, was 25 liters, equals N, which is our number of moles, and that's what we're trying to find. So we're going to leave that stay our variable. R is always 0.0821, and our temperature is 300 Kelvin. All right, so you can do this one of two ways. You can either find out what 0.0821 times 300 is, and then divide PV by that one number, or you can just go ahead and move both of them at the same time, which is what I'm going to do just to conserve space here a little bit. So to get N by itself, we've got to divide both sides by 0.821 times 300. These become giant ones. 1 times N is just N. Now, when you're dividing over here, though, you have to plug into your calculator 0.5 times 25 divided by 0.0821 divided by 300. So don't make that mistake and not dividing by 300, okay? And when you do that, I goofed on my calculator. Let me re-plug it in again. You get 0.51 moles. When you look at our significant digits, we have 2 significant digits here, we have 2 significant digits here, and we have 3 significant digits there because of the decimal point. So that means our least number is 2, so our answer is fine for significant digits, and there you go. Hope this is feeling easy to you by now. If you have any questions, feel free to come find me. Have a great day. Bye.